So good evening everyone. Today I am going to solve one of the GATE 2020 question number 45, which is of 2 marks. So here it is, the total number of compounds showing characteristic Cartman stretching frequency less than the 1700 centimeters in their IR spectra. So we have, so whatever the groups we have, we'll just make a note. We have an acid chloride, we have a ketone, and we have an ester. We'll just take them and see what is their frequency. So this is an acid chloride, ketone, ester. So acid chloride has a stretching frequency of maybe 1800, and this has a stretching frequency of 1715, and this has a stretching frequency of 1735. So before just explaining the question, I'll just tell you what is IR spectroscopy. It's mainly based on Hooke's law. So I'll just explain you Hooke's law and we'll just again carry on to the question. This mu bar is equal to 1 by 2 pi c root of k by mu, where k is basically bond strength. So when the bond strength increases, the wave number also increases. That means indirectly the frequency also increases. Okay. So whenever a compound is in, let's think about whenever a particular is in resonance, think about an ester. Or think about any conjugated carbonyl group. So whenever this is in a resonance, the electrons will shift this side and it will go this side. So as a result, their bond strength character, it will decrease to a slight extent. So which will result in the since the bond strength is decreasing and nu bar is directly proportional to Q, so their bond strength will decrease in the range of how much? 17. Think about as an ester. So 1750, it will decrease in the range of some, I think some 20 to, I think how much? Okay, some 20 to 25. So maximum is 25. So their bond strength will decrease maximum to 25. So you got, I think now you get a basic idea. So whenever whenever any compound is in conjugation, their bond strength will decrease to about some 20 to 25. That means their frequency less than 25, maximum only 25. Okay. So now we'll move on to the question. So here you have how many? 1, 2, 3, 4, 5, 6, 7, 8. In these 8, how many you will have less resonance? So think about, okay, leave this one. So we'll get to this cyclopentanone. What is this? Cyclopentanone is a simple ketone, right? So its range will be some 1715. So there is nothing, not resonance, nothing is there. So it will be in the range of 1715 only. And this one, a lactone. Okay. So this has an ester group, right? So when this has an ester group, so it has a range of some 1735. Think about, right, in 1735, and the resonance will decrease to some, think about a 25. Even if you get to 25, so 1735 minus 25, it is 1710. So not less than 1710, right? So the stretching frequency of this one is 1710, right? And so the next one is which one? The acid chloride one. So I think it is how it is like this: C double bond or Cl. How's the question? So it is like this. So acid chloride has 1800. Even if it is resonance also minus 25, it will be some 1775. So not less than 1775. So your first three options. Then so this one. So basically this one and this one, these three doesn't have any frequency less than 1700. And think about this one, so that is in simple ester group. So it will have a range of how much, some 1735 only, because there is no groups affecting that. Then leave this one also, and this one is a simple ester group, and it will, due to resonance, also a 25 less maybe, then it will be 1715 only. So now we have 1 left, 2 and 3, since be okay. So in this one it is a simple ketone which has a range of 1715. Due to resonance, you less minus 20 or 25, so it will be somewhat less than 1700 only, in the range of some 1670, 1690, 80 to 90, like that. So this one will be have a less than 1600. So when you come to this one, that is also a simple ketone. So a resonance, due to that, so this will be have a something less than 1700, less than 1715, something minus 25 thing like that. So this will also have, so this one is the second one. Now when we come to this third one, this will have something interesting. Right, or we can write it like this. We'll just write it like this: C double bond O, OMe and OH. So this is an ester group. So it has an IR frequency around range 1735. So due to resonance or conjugation, it will have some minus 25. So it will be around 1710. So now it will not be less than 1700. But when you see, this is an electron donating group here, right? So the lone pair of the electrons will migrate like this, and it will go, and it will again reduce the bond strength. So your bond strength will reduce due to extended conjugation. So as a result, your wave number will decrease. So after 1710, it will also reduce to some minus 20. So as a result, so this will have a range less than, so this will have a range less than 1700. So this one will also be your third one, that is have a range less than, your frequency will be less than 1700. So this is an NAD type question. So the answer is 3. Answer is 3. This one, this one and this one. I think you all understood now.